Hey, here we're going to continue with our basic tutorial on how to do user interaction in Python. I'm going to give you 4 examples in this video about how to program this time for numerical input. So in the previous example, we used the input statement to get a lot of strings from Python, and strings are useful, but you can't compute with them, right? If you want to compute some kind of numerical value, you need numbers, and so here we're going to talk about that. If you're watching this video to learn and develop programming skills, just remember you learn by doing, not by watching. And so it would be great if you could follow along as I demonstrate the techniques and write some code and learn from your mistakes, because mistakes are a natural part of the process. And you'll see, I make mistakes too. Learning to program is a skill. It comes from practice. And so write code every day. User interaction is just a piece of the solution, as I said in the previous videos. So we try to break our problems down into smaller pieces, and this particular pattern would be called data acquisition and validation. And everything you see me do is done using idle in Python 3.8, and I'm using Windows 10. So if yours looks different, you may be using different versions, and that's okay. Um, so to our first example, we prompt the user, we get a response, and we convert it to a number. So here's some guidance. So first of all, the input function always returns a string. So even if you type in numerical digits, you still get a string. And so they have to be converted into either integer or float numbers. And so here's how you would convert to an integer is by using the int function on a digit string. And here's how you would convert to a real number using the float function on a digit string. Floats have fractional parts, and integers are whole numbers. So in this example, we'll use the input function to obtain a text response that represents a number, and then we'll convert those numbers using int and float functions. And so here's an example. If you type int of the string 27 in the shell, you'll get an integer returned. And if you type float 27 in the shell, you will get a float return. So let's go ahead and do that. So here we are in the shell, and I could make a string s equals quote, um, let's say 34. And now if I ask for int of, not 34, of s, or string, I get the number 34. Because if I print s, you see I get the string 34. It's in those apostrophe marks, which serve as quotes in this case. And we could ask for a float, and we get 34.0. Okay, so this is the Python shell. If you're not familiar with it, that's what it is. And you can go to File, New File, and you can open a window that then allows you to write some source code and run it. So if we were to do this here, so File, um, Save, because this is already a file, and I want to go to the place where I saved my demo code. And this is going to be, we'll call this numbers. And this is going to be a very simple program. So print. And I always give a title line to my program. So this program is called numbers. And in here, I'm simply going to ask a user for some digits. So let's make a variable called digits, and we'll say input and quote enter some digits. Recall from the last video that I call this the prompt. So this is the user prompt, enter some digits. I will get a string back, and that string will go into digits. And now I need to convert those digits into numbers. So inum, we could call that the integer number inum, and we're going to convert digits and fnum, and this is going to be the float of digits. Okay, so now I've created an inum and an fnum, and now I can print them out. Print inum, comma fnum. Okay, and now we can save it and run it. So save it, run it, and down here in the shell it says enter some digits. So 123, and boom. And so the int number is 123 and the float number is 123.0. Okay, so that's a fundamental technique of how you convert strings into numbers so that you can use the numbers to calculate. And so now we'll do some calculations. So let's write a program called total, and it's going to follow this pattern. It's going to prompt the user to enter an integer. It's going to convert the response to an integer. It's going to use an accumulation pattern to keep a running total. And so the user keeps entering numbers. So we're in a while loop. And then when an empty string gets entered, we exit the program. And in exiting the we exit the loop, and that means we have to print the total and exit the program. Okay. So we had an echo example from the previous video that we will edit to get it to accept whole numbers and accumulate the total. And so each input is going to be converted to an integer and printed so that we can verify it, and then we'll print the total at the end. Okay, so this is what a run of that program will look like. We'll ask, the prompt will be enter a whole number, and then we'll print back, we'll echo back the number, and we'll do that until nothing is entered, and then finally we will print the total. Okay, so let's take a look. So to do this, we need to load that echo program. Okay, so we can close this. And here's the echo program. And so here we want to say enter a whole number, and we're going to get a response. And if we get a response, so now this is not going to be responses anymore, and it's not going to be a string. So it's going to be equal to 0, and we will call it total. So that's our integer total that we're going to accumulate. And so if we get a response, we're going to accumulate on total. So total is equal to, and here's where we have to convert this response so to an integer. So int response, and we want to print it out. So print, and this print will show that we've actually converted the number to an int. So let's do this. So let's have number equals int response. And then we'll add number, and this way we can actually print the number out to show that the conversion happened correctly. Okay, so you entered the number colon, comma, and oops, I have to close that, and number. So that's our print statement that will print it back, and then when we break, we'll have a total that we can print. So the accumulated total, let's put accumulated in, accumulated total of the numbers you entered is going to equal, and we're going to print total. And we don't need this. All right, so we're going to ask for a number. We're going to convert it to an int if it's a number. If not, we're going to break out. If it's a number, we convert it to an int. We accumulate the total, and then, oh, you entered the number, and we feed it back. And in the end, then we present the total. Okay, so here we go. So we're going to run this. Oh yeah, we have to save this. Oh yeah, it's not called echo 3 anymore. Now this will be, we have to cancel, and we want to file save as, and we're going to call this total. Yes, I want to replace it. So here's our total program. So it's going to ask me to save. I say yes, and it's going to run. So now down here in the shell, it says enter a whole number. So what if I enter 20, and then I enter 10? So that will give me 30, and then I enter 5. That'll give me 35, and then I enter minus 10. It should handle that. And so now I should have 25, and now I'm just going to hit enter, and it should say the accumulated total is 25. Perfect. Okay, so so we converted an input string to a number, and we've done some computation with that number and showed that in fact we can get the correct result. Okay, so let's move on to the next thing. So prompt user get numbers and calculate. So again, we're going to do this, only this time we're going to convert the response to a float. And we can now keep a running product instead of a total. And we can print the product and then exit the program. So we'll edit this total program to accept whole numbers, and we'll accumulate the total by multiplying. Okay, so we'll get a number, and then we'll feed back the number, and then we will keep a total of the multiplied numbers, the product. So let's see. So this one's going to be called product. And we're going to take that, and we're going to save as and product. Good. Yes, I want to replace it. Okay. So again, so now we don't need to enter a whole number anymore, because now we're going to convert the number to a float. So any number put in here is okay. And instead of adding those numbers together, we will be keeping a running product, which means that if I start out with my total, so we won't call that total anymore, we'll call that product. If I start out with my product as 0, then everything will be 0 after that. So I need to start out with a product of 1. And this is product. So I get a number, I convert it, you entered the number. So, and let's change this slightly. So now, number, comma, will multiply the running product. Okay. And then in the end, when we're done, we'll have an accumulated product, and we will print the product. Okay, so enter a number, convert the number, keep the running product, feedback the number to show that it actually converted, and then finally display the result. Here we go. Okay, enter a number. So let's enter 20. Okay, so notice I entered 20 without a decimal point, and 20 came back with a decimal point because now it's a float. Okay, enter a number. So I'll enter 0.1. So when I enter 0.1, now I've multiplied 20 by 0.1, and that's going to be 2. And now I'm going to enter a number, let's say -5. So now I have 2 times -5. That's going to give us -10. And let's hit enter and see what happens. So we should have -10. And our accumulated product is -10. There you go. So, so that's how you would do a float number. And we get our product. And that's all fine and good as long as the user behaves theirself and types in a valid number. But people make mistakes. So in the shell, we can try executing this. So if I ask for a whole number and I get this instead, here's what happens. So if I ask for a whole number and I get some floating point number, so let's make s equal to quote 3.14 quote. Okay, so now we have a string. I can print it out. There I see the string, and so if I ask for float of that, that's no problem. But if I ask of int of that, we explode because this is not a valid whole number. It's not a valid integer number. It has a fractional part. So so we want to keep things from exploding in that way. We could also do that with float. We could have a number expressed this way, like 3.25 is what this number would designate in a string, and so we could have s is equal to 3.25, and now neither int nor float will convert this correctly. If I say float of s, so so that's a problem. We want to prevent our programs from generating those runtime errors, which are what we call exceptions. So so runtime errors occur when you try to convert a string that doesn't completely comply with how numbers are expressed in Python. So we can avoid them by trying to validate the input. One possible solution would be to try to check the string using a function called isDecimal. So isDecimal is actually a string method, and so if we said s dot is decimal here, it would say false, and then we would know not to convert it. However, there's lots of places where this will say false when we have a perfectly good number. Um, so I can make a string 3.14. Now that's a perfectly good float, but isDecimal is going to say it's not, because the decimal point is not a number. So isDecimal only responds to numerals. So that's one possible way to maybe um, check an int, you might think, but it would have to be a positive int, because is decimal 23 is decimal is going to come out to be true. Boom, we know that's good, but what if the number were negative? In that case, if the number were negative, quote, minus 23, quote, that's a perfectly good integer, but if we say is decimal, boom, it says it's false. Okay? Now, we could go through a lot of complicated programming to try to deal with the decimal points and the minus signs and so forth, um, but we want to keep things as simple as possible. So isDecimal is a string method. It returns true if all the characters in the response are these digits, these numeral characters. Um, and it will convert any positive integer, as long as you didn't put in the plus sign, correctly. But isDecimal won't validate a negative integer. It won't validate a float without some assistance. So if you want to completely validate a string with isDecimal, well, you can't do it. You need to do other things, and it gets messy. But let's go ahead and demonstrate um, isDecimal by modifying the total program. Okay, so let's do that. And so we'll use this only for the most simple cases of positive integers, and we'll do something like this. So let's go back to our total program now. So file, recent files, we have our total program. There it is. We can close out this product. And here we want to call this valid total. Okay, and we'll save this as valid total. Yes, I want to replace it. Okay. So we're going to get a response, and if there is a response, now we need to also check to see if the response is valid, and we need to ask for a positive whole number. And back in the example, so here, if we type in something invalid, we should give some feedback that says that 4.0 is not a valid integer. Okay, so that means here, if response dot is decimal, we can do these things, but If it's not, we want to print out that print out our string. So now we want to print response, and here we want to print the response in quotes to separate it to show that it's a string. And so we take that plus response. Remember, we're concatenating strings here now. And now plus, we're going to close quote and say is not a valid positive integer. Close that with the apostrophe and close that. Okay, so let's expand this a little bit so we can see it all. Okay, so if our response is decimal, then we got no problems and we can add those things together. But um, if it turns out that it's not valid, then we print out, give the user some feedback that it's not valid. Okay, here we go. So valid total. Whoa, told you I'd make an error. So here's an error here. I forgot to put the colon after the if. Okay, hopefully there are no more syntax errors. So there we go. Okay, so now down here, enter a positive whole number. So I enter 10. That's fine. I enter plus 10. That's not a valid positive integer, even though of course it is, right? I could add 10.0. That is still not a valid positive integer, and I certainly can't put in a negative number as well. So far in our total we have 10. I can put in 20. That makes 30. I can put in 30. That makes 60. And if I enter nothing, I should get accumulated total is 60. There you go. Okay, so not the best way to validate your user input using using isDecimal, because it's really intolerant of any things that um, could possibly be normal parts of a number. So example 4 of people make mistakes. So runtime errors can happen in a variety of circumstances, not just here. And runtime error is generally called an exception. So now we're concerned with making sure our input strings are valid representations. That's what validation is all about. And so int will throw an exception if things aren't right, and float will throw an exception if the string isn't right. So what we want to do is handle those exceptions, or we say catch these exceptions, and the way we do that is with something called a try except block. So we can make a try block to do the conversion, and then if an exception generated, what happens is we execute an except block instead, and so we won't have to deal with isDecimal or anything like that. So valid product. Let's demonstrate now catching and responding to a runtime error using try except and doing the product routine. So we'll start out with our product program, and we should get some kind. We should modify it so we get some kind of user interaction like this. So enter a number. If the number is valid, we just feed it back. Enter a number, we feed it back. Enter a number, we feed it back. But if we enter something like this, we feed back that it's not valid. Okay, so let's go there. So we're going to go take our recent file, which is our product. And this time, this will be valid product. And so we're going to enter a number. And when we do this float, this is where we have to implement the try block. So we're going to try to convert the number to a float. Try. Let's expand this out a little bit. Oh, come on. Thank you. Okay, so we're going to try, and that means we're going to take these and indent them. They all become part of the try block. If there's an exception, so except, now we're going to feed back that the number was not a valid float. So print, and the same thing we had before in quotes, concatenated with response, concatenated with a apostrophe and a quote, and then is not a valid float. And little emphasis there. Okay, so that, and we should be done. And it's as simple as that. So when Python tries to make this conversion, it will generate a runtime error. When that runtime error happens, then we go down and execute this except block. Okay, so here we go. Let's try it out. So we have the correct name for the file, do we? Oh, we don't. So valid product. So we have to file, save as valid product. Okay, and let's go. So enter a number. So 10, perfectly fine. So 10 will multiply the running product. And 0.1, that will give us 1. That's just fine. We'll multiply the running product. Let's try -5. -5 will multiply the running product. So now we have -5. And we can say -2 minus. Let's try that. That's not a valid float. But you see, we didn't get all that red text. We didn't get all of this that we would get if we hadn't caught the runtime error. So enter a number. So where are we? So we have 10 times 0.1 minus 5. So our multiplied value is 5, and we'll give another -5, 0.0. Now we should have plus 25, and we'll multiply that by, let's see, 0.4, and we should get 10. Let's see, enter a number. The accumulated product is equal to 10. So there you go. So we've done some work to handle numbers. We and validate numbers. We're letting Python go ahead and do the validation, generate a runtime error, and we catch that runtime error. So we went through 4 different examples, and it's important to review here. So input prints the prompt and returns a response, and the response is always a string. And if a string is empty, it evaluates to the Boolean false so that we can exit a loop if we like to, or do something else. We can test it in an if function, for example, an if statement. And so for numerical calculations, the strings have got to be converted to numbers. So int and float are the functions that convert to numbers. IsDecimal can be used to validate a very simple integer input string, but it can't handle plus sign, minus sign. It can't handle anything It doesn't validate anything that has plus, minus, decimal point. It only checks for numbers. And then try except blocks can be used to catch and respond to input data format errors. And there's still a lot more to talk about. So this is the second video about user interaction, and still there's more things to talk about. Like, what if we want to put multiple numbers in a single input line? How do we do that? And how do we validate variants of all kinds of statements that we would ask a user to respond with? So so, but those are lessons for another day. So for now, thanks for watching, and I hope you learned something about using the input function to validate numerical data in the Python console, and I hope you'll consider liking this video and subscribing to the channel so that give me the opportunity to make more videos, and feel free to comment if you like about how I could make these better. Okay, so thanks for watching, and we'll see you next time.